Hi everyone, welcome back. Index Law 3. What happens when we're going to use division? What happens to the whole question? So if I started with something simple to start with, like 2 to the power of 4, which means 2 by 2 by 2 by 2, and I divide that by 2 to the power of, let's go 2, that means 2 by 2. So this means we're going to go 2 by 2 by 2 by 2. Now if you're slow on the calculations of them because you're not happy with your times tables, 2 2s are 4, 4 2s are 8, and 8 2s are 16. So what we really have here is just 16 divided by 2 is 4. And you could look at that and go, how many times does 4 go into 16? And you could go 4, 8, 12, and 16. So 4 goes into 16 how many times? Goes in 4 times. So 16 divided by 4 is 4. So that's what we could do and calculate the whole thing. But what we're learning is a method that's going to help us as questions get harder. So if I wrote that as 2 to the 4 divided by 2 to the 2, and instead of having a divide written this way, we wrote the divide that way, we've still got 2 to the 4 divided by 2 to the 2. Let's have a look what it means. So this means 1, 2, 3, 4. Remember, we're talking about a base of 2. So this is a base of 2, so they're all 2s. And then we're going to divide all of that by a 2 squared, which is a 2 by 2. This says write the 2 4 lots of times, 1, 2, 3, 4, with multiply in between. This means write it twice with a multiply in between. And again, you're not seeing the purpose of this yet. This is what I talk about maths, keep saying it to people, is that you don't see the purpose when you first learn it. People say, what are we going to use this for? So that's coming. So the top up here now, have a look what happens. We have one rule for fractions, is you can cancel any top of a fraction with any bottom. So a lot of people still struggle with their fractions. I've got a fair bit in terms of fraction videos on another playlist on fractions if you struggle with fractions. So what do we mean by cancel? If I go 2 into 2 goes once, I can replace that 2 by a 1 as long as I can go 2 into that 2 is once. So I can cancel any top with any bottom. It's not that it's gone, it becomes a 1. Now I can cancel that top and make it into a 1. And I can cancel that bottom and make that into a 1. So what I'm left with on the top, I'm going to write it out for once, is 1 by 1 by 2 by 2. And on the bottom I've got 1 by 1. Now, any of you simple maths, 1 by 1 is 1, and there's another 1 by 1, 1 over 1 is 1, you don't need to write it. I'm now left with how many 2's? I'm left with 2 of them. So I can write that as 2 squared. So have a look at what we started with. A 2 to the 4 divided by a 2 with a 2 ended up with a 2 to the power of 2. Let's do another one. Don't want to go too crazy on it. If we went 5 to the power of 5 divided by 5 to the power of 3, what have we got? Let's have a look at that. So it's 1, 2, 3, 4, 5 on the top and 3 on the bottom. Now, instead of saying I'm going to cancel and write ones, it's very easy if you want to. It doesn't matter where you cancel them. They will cancel out, they will cancel out, they will cancel out. When we say cancel out, they all become ones. So what are we left with? We're left with a 5 with a little 2 above it. Of course, you could have written 25, but when it gets harder, you won't want to work out what the big numbers are. So, in the previous video, we talked about if you had 5 to the power of 5 times by 5 to the 3, the law is when you multiply, the bases stay the same, the bases stay the same, and you add the top numbers. So that's 5 to the power of 8. 1, 2, 3, 4, 5, 6, 7, 8 of them. This law is when you're dividing, and instead of adding them, some of you already know it, is you're going to subtract them. So we can go 5 take 3 is 2, but the 5s are the base of 5, and they stay with the base of 5. So there's an intro to division. All it is, go back to the original question though, I got 2 to the 4 divided by 2 to the 2. I could have written that just as 2 to the 4 take 2 is 2. So the baby numbers or the little numbers favour the baby laws. So it turns a division into a subtraction. So if I wrote it over here, one last bit, if I had 4 to the 6 divided by 4 to the 4, the 4s stay the same, the bases all the time, same, but the 6 and the 4, when the division becomes a subtraction. One thing I do like to talk about with it is in the middle of a divide sign, you've got like a little subtract sign. So when you're dividing with index laws or with exponents, you go 6 take 4. When you're multiplying, it's like the multiply and the addition are related to each other. I don't know historically whether that's ever been the case, but they seem to be related to each other, which makes sense. And then the division seem to be related to each other as well. So if you need a picture in your head that you keep forgetting or you don't quite understand, some people just learn the rules. At times becomes a plus for the baby numbers. And remember, babies can't multiply, but babies can add. Babies can't divide, but they can subtract. If I ask them, I've got 3 duckies, and they take away 1 ducky, you've got 2 duckies. Probably a bit hard if I said, I probably could do it, depending on their age. 6 duckies take 4 duckies. But really, a lot of people just want to say to you as maths teachers, leave the 4s the same and subtract the powers. The trouble is, will you remember it? Will you get mixed up with it? Thanks for watching.